Okay, hello everyone. Let's go ahead and take a look at the derivatives of inverse trig functions. What we'll do is we'll go ahead and take a look at how to derive the derivative of y is equal to arc sine of x. We'll go through the entire process and then we'll do it together for y is equal to the inverse cosine of x. So let's start off. Y is equal to arc sine of x. Well, being that we cannot determine the derivative directly, we'll go ahead and take the sine of both sides. So if we take the sine of both sides, notice what we come out with is the sine of y is equal to the sine of the arc sine of x. These two, of course, are going to be inverses of each other, and so we come out with just x. So now we can go ahead and differentiate implicitly, and we're taking the derivative with respect to x. So we find that the derivative of sine of y with respect to x is going to be cosine y times by d of y over d of x, equaling the derivative of x with respect to x, which is just going to be 1. So what we want to try to do now is just solve for d of y over d of x. We just divide both sides by the cosine of y. Now, what we're trying to do though, is we're trying to get everything in terms of x. So what I'm going to have to do then is I'm going to have to resubstitute what the value of y is for, which is the arc sine of x, and come up with this expression here. Now this is where we come across with cosine of the arc sine of x. And so what we have to do is we have to use some of those methods that we described before to go ahead and determine exactly what this would be in terms of x. So we know that this is an angle theta. So we'll go ahead and let theta be equal to the arc sine of x. If we take the sine of both sides, we know that the sine of theta is equal to x. This is then going to be able to generate this triangle here, because here's the angle, the sine of theta is going to be x over 1. So I know that the opposite side is x, the hypotenuse is 1. That means that the adjacent side has to be the square root of 1 minus x squared. So what that means then is that this here can then be simplified to just the cosine of theta. But again, we still have to get everything in terms of x. Cosine of theta is just going to be this divided by that. And so what we know then is that the d of y over d of x is just going to be 1 over the square root of 1 minus x squared. So there you go. In the beginning here, y is equal to the arc sine of x. If we wanted to go ahead and find the derivative of that, it's going to be 1 over the square root of 1 minus x squared. So interesting thing to note as well is that if you take the derivative of an inverse trig function, you no longer have a trig function. Like with the other basic trig functions that we have, you actually come out with a rational radical function. Okay, so let's try this one together and let's see if you guys can do it. Now, we'll go ahead and give everybody just moments to go ahead and do it step by step. Let's see if you can do it. Okay, so what we need to do is we need to go ahead and take the cosine of both sides. Okay, that would mean that the cosine of y is just going to be equal to x. Okay, now what we want to do is we want to differentiate implicitly. So the derivative of the cosine is the negative sine of y times it by the derivative of y over d of x. Again, because we're differentiating implicitly there with respect to x, that of course is going to be equal to 1. So then d of y over d of x is just going to be equal to negative 1 over the sine of y. Now, again, remember we're trying to get everything in terms of x, so we need to go ahead and resubstitute that in there. So d of y over d of x is going to be negative 1 over the sine of the inverse cosine of x. Now, remember again that that is just going to be a particular angle. So if we go ahead and draw a right triangle, and we let theta be equal to the inverse cosine of x, and that means that the cosine of x has to be equal to, the cosine of theta has to be equal to x. So now we can label our sides of this right triangle. That is x, that's 1, that's going to be the square root of 1 minus x squared. So what we can do then is we can go ahead and say that d of y over d of x is the same thing as negative 1 over the sine of theta, because that's what the inverse cosine of x was. So we can just do our substitution now to get everything in terms of x, and the sine of theta is just going to be equal to the square root of 1 minus x squared. Okay, so notice the interesting thing about this one as well is that the derivative of the inverse cosine of x only differs from the derivative of the arc sine of x by a factor of -1. Okay, so there you go. That's how we can go ahead and do that. So I will go ahead and invite you also to challenge yourselves and see if you can go ahead and determine the derivative of the arc tangent of x. Okay, and we'll go ahead and take a look at that the next time that we have class. So there you go, derivatives of inverse trig functions. Starting off with our inverse trig function, differentiating implicitly, using right triangle relationships to enable us to come up with a form of the derivative that is just in terms of x. Okay? So give it a shot. We'll see how we do the next time that we meet. Okay, bye-bye.